smart transformer breathers and how they help keep your transformer dry. So we'll first dive into the application of a transformer breather, some of the differences between a traditional breather and a smart breather, and then we'll take a look at the Qualitrol smart breather and how it can help you and the benefits that we offer. So what does a breather do? A breather is designed to ensure that moist atmospheric air does not enter your transformer. So with expansion and contraction of the transformer oil on a conservator style transformer, the transformer inhales or exhales air from the inside to maintain a constant pressure and with the changing oil levels in the conservator. So without a breather, the moist atmospheric air can enter into the transformer and then it can saturate the oil. And if that moisture saturates the oil, it can break down, things like the bladder, the insulation properties of the oil, the solid transformer insulation around the windings, and all of this can limit the transformer's expected lifespan. So the current options for transformer breathers on the market, there are two big categories. So we consider them either a smart breather or a traditional breather. And a traditional breather utilizes a color changing silica gel, which alerts you as the utility when you need to change that silica gel, when the silica gel can no longer absorb any moisture. And if it is fully saturated, then there's just moisture being allowed to be inhaled into your transformer. So those operate on the basis of if the color is indicating it needs to be changed, you need to send a crew out to the field, and that silica needs to be replaced. So a smart transformer breather, or electronic or self-regenerating, some of the terms that are thrown around there. The smart breather utilizes an algorithm to know when the transformer is breathing, and it will regenerate the silica gel automatically in a proper time zone where the transformer is exhaling, and it can regenerate the silica and expel all the moisture out of the silica. So the silica can continue to dry the moist atmospheric air that's being inhaled into the transformer. One of the common traits between the traditional breather and the smart breather is that they both utilize a very similar silica gel to dry the air that is being passed into the transformer. So some of the advantages of a smart breather is that it requires no maintenance over time. So you eliminate the need to send a crew out to the field and replace the silica. You can remotely access it to look at things like the RH of the silica, the temperature, the regen cycle, anything like that. It can also data log, so you can see how many times it regenerates, how much your transformer is breathing, and things like that. You can kind of trend your transformer's operation over time through the breather's operation. Some of the advantage of a traditional breather is that they're very cheap up front. It's a very low-cost investment to install one of those on a transformer. But some of the disadvantages is that you need to send a crew out on a time schedule or based on visual indication. So it's either you need to have a visual inspection schedule, and then which would turn into a replacement schedule. And then they offer, obviously, no data recording, no trending, things like that. So as we mentioned, traditional breathers operate on the basis of visual indication to know when the silica gel needs to be replaced or taken out and heated manually to regenerate it. And it's strictly based on color changing. There's no data, no sensors. Traditional. We sometimes we joke around and call them a dumb breather. And these are generally very cost-effective solution for the initial installation, but over time it requires constant maintenance every 6 months or a year to change the silica. And sometimes it's kind of difficult to know when the silica is completely saturated. Is it actually doing its job still? And at any time, it can allow moisture to be sucked into the transformer if the silica becomes fully saturated, either quicker than expected and the crew doesn't get to site in time to do the replacement, or the visual indication, the color changing maybe stops working. There's a lot of variables there. Some more of the advantages of traditional breathers: the small initial investment, ease of installation. There's no electrical connections. To reiterate on the negative sides is that it requires regular maintenance after the first installation. The silica gel either needs to be disposed of or regenerated. Some of the old silica gels are very toxic if they contain cobalt blue, the coloring. That's an environmental concern now. And then the maintenance is one of the biggest things. So the smart breather is a maintenance-free, self-regenerating breather. There's a lot of terms that are used to indicate a smart breather, but it utilizes the same silica gel that's found in a traditional breather. In some applications, they use a moisture sensor to determine when the silica gel needs to be regenerated or dried. And they can regenerate on either percent RH, the weight of the silica, and most of them choose a time during the transformer's breathing cycle to regenerate, to eliminate the chance of any moisture being inhaled into the transformer. And in this diagram here, you can see the way it's regenerated is that there's a heater inside the desiccant chamber. And in our case specifically, we have these aluminum fins that radiate that heat through the silica to get it up to temperature to drive out that moisture. And the moisture will kind of evaporate or turn into steam essentially and condensate on this outer tube and then drain out of the bottom. So the pros and cons of a smart breather. The big pros are that you completely eliminate the need to send crews out to site, no maintenance. You eliminate the maintenance aspect of a breather. You don't need to dispose of the silica gel. You don't need to manually regenerate the silica gel. And you don't need to guess if the silica gel is saturated by looking at it, because there are sensors that can determine that on their own. And then you also have the added benefit of data logging or communications for trending that data. And then the one downside is that they are a little bit more costly to install up front. So it's a larger investment, but it pays out over time by eliminating the maintenance costs and the time on site. So a lot of smart breathers operate on the same principles that the transformer, so you can see the cycle here. So it starts with the transformer inhaling. So step one is the atmospheric air is obviously pulled through the silica gel and it is dried out before entering the transformer. Step two is that during a transformer's exhale cycle, when the desiccant is fully saturated or needs to be regenerated, the regeneration cycle is activated. And the moisture in the silica gel is condensed on the side of the tube and drains out the bottom. And that is kind of the full cycle there. So the smart breather should be able to determine when the exhale phase is and when the best time to regenerate is. So now we're going to get a little bit more in a little closer look on the Qualitrol Smart Transformer Breather and what we have to offer. Some of the new features with the new the Gen 2 version, and an overall view of the breather. So with our next generation of breather, we've updated so far as our 1 kilogram and our 2 kilogram breathers. So our 1 kilogram breather is good for 30,000 liters of oil or 8,000 gallons. And the 2 kilogram breather is good for 68,000 liters of oil or 18,000 gallons. And these sizes are determined by either the size of the transformer and I guess the breathing cycles of transformers, those sizes. So these are, not exact numbers, but it's good guidelines to go by. So here's an overview of the new Qualitrol Smart Transformer Breather. So here you can see each of the physical features of the breather. So the first thing that stands out is that there's no longer any external cabling. And that's a big feature because sometimes the external cabling can be, affected by, say, an animal chews a cable, and that causes a short, or one of the connection points on the cable becomes loose and it lets moisture or water into the enclosure, into the electrical enclosure, which is never good. But you can see just the overall physical fit of the new breather. You have the top up here is where your mounting flange would go. So there's a threaded port on top of the breather. We have multiple mounting flanges available, some DIN standard flanges. You can also do a flex tube going to the conservator. This is also where the sensors are located. So the pressure sensor, the humidity sensor, and also the solenoid that closes during the regeneration cycle. Here in the middle is the glass tube, and inside that glass tube is the silica gel that is located in a mesh with the heater inside of that. The water outlet on the bottom. This has a stainless steel filter on the bottom to prevent any either bugs or big particulates from getting in the breather and contaminating the silica. And then the front here is the IP65 control box. And then another change that you might notice here from our previous generation is that we went from 3 front LEDs to a single side LED. And we'll talk a little bit more about that in a few slides. So a big feature that we added to our Gen 2 breather is a test button functionality. So what the test button does is that it runs through all of it essentially checks all of the system statuses. So it makes sure your pressure sensor is working, your RH sensor is working, your solenoid works, and it also checks that the heater is working. So this takes about 15 minutes. And when you press the test button, you can let it sit. You'll hear the relays click on. You can actually test all of the relays too. They will all close. And if you let it sit, you'll be able to actually feel the heater actually heating up. It takes about 15 minutes to feel that. So that's a nice feature to make sure that the breather is functioning as it should. Another added feature is data logging. So on the previous model, we did not have any data logging. Data logging is really useful to kind of see how the breather operates due to changing climates and also changing loading patterns change of loading patterns on the transformer. So our data logger will log all of the values that are in the breather's firmware. So it takes a timestamp, it records the humidity, the temperature, the error state, and the relay status. So the error state is dependent on all of the parameters. So the RH, make sure all the sensors are working, all the communications are working. And then it will also let you know if it's in a regeneration mode, if it's in a post-regeneration or a cooling mode. It records all of that. And it records every 15 minutes and can store for over 20 years. So the breather also has some communication options. I touched on the 2 relays. We'll talk more about those in a second, but the breather has an optional 4 to 20 milliamp output, which is the percent RH of the silica. So it's the constant percent RH reading from the breather, and that's over a 4 to 20 milliamp loop. The USB port is for configuring the device, and that's standard on all units. So you would plug into this. It's a USB B port or a printer cable. You plug in and then you can connect to the software. And then we also have a RS-485 4-wire Modbus as an optional communication feature. So alarming. So I talked about the change in the LEDs. So here's where we'll go over those. So we now have, instead of 3 external enclosure-mounted LEDs, we have a singular side-mounted LED. So the side-mounted LED, in a normal state, it will be solid green. So everything's operating as normal. All parameters are okay. Everything is good. It'll be solid green. So if it is blinking green, that means it's regenerating, which is also normal. So green, normal, regenerating, it's a normal mode. And then if there's any error that requires further diagnostics, it will be solid red. And just because it's solid red doesn't mean that the breather's not functioning. If this ever goes solid red, it will go to a time-based regeneration. And we moved away from the 3 front LEDs from some customer feedback that it was a little bit confusing to know if the breather was operating properly or not, because in regeneration mode before, there was an amber light, and it got a little bit confusing. So we added the diagnostic LEDs to the board now. So we still have 3 LEDs that will tell you the current status of the breather. So inside the enclosure, right on the PCB, we have 3 board-mounted LEDs. So if you see a red LED on the outside, you can open the enclosure and then do further field diagnostics from the 3 board-mounted LEDs. And they'll tell you all of the same error states that we told on the previous generation with the front-facing 3 LEDs, but now they're in the board. And you can see here, they'll tell you normal mode, regeneration, cooling, post-regen, communication error, Modbus error, pressure error. So here are the 2 relays that are standard on every breather. So both of these relays are Form C contacts, Form C relays. One is for the regeneration status of the breather. So is the breather currently in a regeneration state? So is it regenerating? That's the regeneration one. And then the error status, is the breather displaying any error code? So that can be anything from, a Modbus error or anything. So you'll get a relay closed if there's any error, any abnormal condition with the breather. And both of these relays can be configured for fail-safe mode. So this is really useful because you can put the error status in a fail-safe. So when it's powered on, your normally closed and normally open swap, and then that can be used as a power status relay. So if the breather ever loses power, it'll close on that normally open, and then you'll get an alarm for that if there's ever, for any reason, that you lose substation power. So some more advantages with the new Qualitrol Smart Transformer breather. So we really upped the physical design of the breather, and this was, based on a lot of great customer feedback that, a big thing that everybody wanted was no more external cables. So now we routed all of the cables inside the sensor block into the control enclosure. So there's no more external cabling where it can't get caught on anything in the field. No animals can have any impact on it. Less points of moisture ingress. So all of these connection points are potential leak paths. So it's an overall, more robust design. And in addition to that, we also made this control enclosure IP65 as a standard, and the entire breather is also C5M coated. So C5M is kind of a standard for high durability corrosion protection. Another big feature with the second generation breather from Qualitrol is that it's truly universal in the sense that it can be applied on either the main tank conservator or the low temp changer conservator. Previously, some of you might have noticed is that you would have a breather part number like an STB 101-1 TC, which stood for tap changer, because there's different firmwares for different breathing cycles. So a tap changer might have a more sporadic breathing cycle than the main tank would, because it's obviously less volume of oil, so it breathes a little quicker. It might not breathe all the time. So now with a new breather, it can automatically detect what tank it is on and adjust the firmware accordingly. And this is continuously done. So if you install it on a transformer and it's not in service yet, once it kicks on, once you energize and it starts its breathing cycles, it'll recognize I'm on an LTC, and it'll switch to an LTC regeneration mode. And then at any time, if if the breather detects a breathing pattern, so a normal breathing pattern, it'll revert back to a learning mode. So then it'll begin to look for the exhale cycle again, and it will begin to pick, a window where regeneration is possible. So on the topic of picking a regeneration time that is best to, dry out the silica where the transformer is exhaling, we use a pressure sensor technology. So every 15 minutes, we close the solenoid and sense the pressure, either if it's an inhale or an exhale. And we track where those exhale cycles are. So we'll track the time of day. So say maybe it's, middle of the night, or actually if it's morning. So the transformer, increasing load, temperature's increasing, it's breathing out. So it breathes out from maybe 6 a.m. To noon. We're going to be tracking that pressure increase over that time. So we use real data to know when the best time to regenerate is. So we have 3 regeneration modes with the new breather. So we have learn mode, which we just discussed. It'll sense for the continuous exhale phase over a certain time period, and it will, once it needs a regeneration, it will wait for that time, and it will regenerate in that window. LTC mode is when it doesn't, the breather doesn't sense a consistent breathing pattern, and the breather will revert to a time-based regeneration. And then saturation mode is if the silica gel is very saturated, so the humidity level goes above a certain point, it will regenerate as soon as possible if it's in that saturation mode. And the 65% is configurable in the software. So you can set the saturation mode as high as you need it. It's very dependent on climate and time of year, things like that. So if you're unsure with that, feel free to reach out and we can kind of guide you through that. So a little deeper into the learning mode. So you can see here, this table is, a 24-hour window. And, transformer breathing cycles aren't always the same. It might shift over time or different seasons, different times of the year. So you can see here, every yellow block is where the breather was, tracking a positive pressure on the conservator outlet pipe. So the transformer is exhaling. So what it'll know, exhale, exhale, exhale. And it'll pick a 3-hour window when to regenerate. So that's how our learning mode works. It's based on pressure. And it'll pick the best 3-hour window when it knows the transformer is going to be exhaling. So the regeneration threshold. So as I mentioned, there's 3 ways to trigger the regeneration. Either a time-based, you can do it through the relative humidity threshold, or we have a new feature, which is moisture parts per million in the desiccant chamber. And we'll talk a little bit more about moisture parts per million in the coming slides. But these are the 3 regeneration modes. The time-based is set with a dip switch on the PCB. So you flick these 2 switches and they'll give you either 10, 40, 70, or 100-day regen time. The RH humidity threshold, you can see here on the software, it can be configured very easily through here. And then moisture ppm, which is a new feature, can also be configured through the software. So let's talk about the ppm, parts per million of moisture regeneration threshold. So ppm is, we wanted to add this because RH isn't always the best indicator of moisture in the desiccant chamber. So moisture parts per million is a true measure of the amount of moisture in the air, whereas RH is a measure of how saturated the air is, not a measure of the absolute amount of moisture in that air. So as temperature changes, percent RH can be a misleading indicator of the true moisture level. So these diagrams kind of speak a little bit louder than words here. So both of these, consider both of these at 25% relative humidity. They're at the same pressure, but they're at different temperatures. So as you can see, at 25C, there's a lot more ppm of moisture, even though both of these readings are 25% RH. So where this becomes an issue is that if you have 25C in the afternoon and then you drop to a really low temperature at night, there's a lot more moisture being inhaled into your transformer. But if you were using ppm, you could more accurately track the saturation of the silica and get on a better regeneration cycle. So here's another diagram that shows it. So consider both of these, 30% full, whereas the small glass is cold air and large glass is warm air. So warm air obviously can hold more moisture in a vapor form when it obviously it doesn't condense, whereas cold air cannot hold as much moisture. So you think about both of these, they're both 30% full, but which one really has more water? And that's what ppm tells you. And that's the real benefit of that. So another thing that we added is our new standalone software for the breather. So on the previous generation, you had to use a serial terminal communication software, third-party terminal, serial terminal, or like HyperTerminal or PuTTY, one of the two. And now we have a really user-friendly standalone software that makes it incredibly easy to set up the breather. You can get in the field, you can plug it all in, you can hook it all up, power it up, plug into it, and set the settings that you want. And I'd say less than 10 minutes per breather. It's really user-friendly. It makes it really easy, and it gives a full dashboard. I don't have a snip of it here, but the dashboard will tell you all the current settings, like the time that's loaded to the device, the current RH, the last regeneration time, all current parameters, the relay statuses, if it's in regeneration. You can view all of that through the software. Another new benefit of the second generation smart transformer breathers from Qualitrol is that each of them are now a configured model, and it makes it a lot easier to pick and choose the features that you really want for your breather. So in the past, we would ship every single one of them with a back mounting plate, and we would go in the field and we would see that the mounting plate isn't even being used, so it's just hanging off the back of the breather. So we decided, why not make that an optional feature? So all of these features that you see here, these can be selected on a configuration form, and from the configuration form you can get a configured part number, which will look like this. So the new part number nomenclature is STB000, and that's what the new part numbers will look like. So things like communications and data logger, those are now features. So if you don't have any interest in using any communication options, you can say no to those, and now we can offer a much more competitive price. So pick and choose what you need. So some specialty applications that we can do with the breather are, polar extreme, so we can go down to -60C. In this application, we'll add a heater to the outlet port to make sure none of that regenerated moisture that's being driven out of the silica freezes on its way out of the breather, because that would clog the inlet port, obviously. And then we also have an offshore extreme, which is a breather fully made out of 316 stainless steel. And then we'll make the circuit board enclosure out of fiberglass, and then the tube is obviously glass.